Hi guys, welcome to Molly's Maths, 22nd of January. Um, got some exciting questions today. Got some exciting music. Good music. Got a bit of the Clash on today, a bit of London Calling. I fought the law and the law won. My daddy was a bank robber. Ooh, sounds good to me. I love this sort of stuff. What sort of music have you got on? Settled in? Let's move on then. Let's move on to the first question. Ooh, what have we got here? What have we got here? Right, we got a group of shapes. Yeah, good shapes. So, question one: which shape is mathematically similar to shape B? Well, we've got a lot of different shapes here. Looks a bit like battleships or Tetris if you look at the different shapes. But so they're all slightly different. Well, let's have a look at shape B. Shape B is this one here, shape B. Now, what can you tell me about shape B? It's a rectangle, so let's write it's a rectangle. Rectangle, so it's a rectangle. Yeah. So how many these other shapes are rectangles? Well, A's not. D looks like an L. E looks like one of these battleship things when you play the battleship game. H is a rectangle, so H possibly, and F's a rectangle. G and I are not rectangles, so we've got H and F as possible mathematically similar to B. Now, mathematically similar means that the shape is, to all intents and purposes, exactly the same in proportions. So if you made it bigger or smaller, or even if it's rotated, it's going to look the same if you zoomed in and zoomed out. So B, if I look at it, it looks like it's 1 square by 2. And if I look at H, it doesn't look quite the same. It's 1 square high, but it's elongated. It's very long. So I wouldn't say that shape fits to B. Now F, it looks similar. I think if we rotated that round, it looks mathematically similar. It's just been enlarged. And so basically, if I rotated it round, I'm going to draw something on the side here. So I'm going to draw a simulation of sort of B. So B, if this is a shape B, my pen's not that brilliant, and if I rotated F round to 180 degrees, and I sort of draw it over the top, it would look something like this. So basically, if we put B in there and F there, F looks exactly the same as B, but it's scaled up. It's a slightly bigger shape, but it is pretty much the same, but it's just been doubled in size. So F would be the answer. So F is the answer, although it's scale factor 2. Scale factor 2. But it's the answer. F and B are the same. I hope that's clear. It's something you probably need to look at and practice and do some more shape work. But hopefully that's helped. Let's move on to the next question. Or it's the old one of these money questions, isn't it? We're looking at money. So question 2, we need to express 20p as a fraction of £5. Now, fractions, when you've got the denominator and the numerator, the denominator being the bottom and the numerator the top, they need to be, so the top just represents a part of what the whole is, the bottom. So if we put 20p on 20 on top, because that's the top, and £5, well, £5 is not the same as pence, is it? But we know in £1 equals 100 pennies. So £5 equals 500 pennies. So basically we just put 500 underneath, and that's your denominator. Now, is that right? Have we finished, do you think? Or can we simplify it? I think we can simplify it. So basically, how many 20s have we got in 20? So in 20, we got 120. But how many 20s in 500? Does anybody know? You can use your calculator, but I know that there's 5 20s in £1. So how many 20s would there be in £5? I think the answer is 25. So we've divided that by 20, and we divided that by 20 to give us the answer of 1/25. So the next question is we've got a number here, 0.065, and we need that written down as a fraction. So again, the denominator at the bottom, we would start with 1. And at the top, we've got 65. So if we put the 1 there under the 65 like that, you could see that we need 1 with 4 noughts. Let me just rub that out and create a bit more space so we can see it a little bit clearer. So what I've just done is put the numbers underneath in decimals, but we don't want it in decimals. So underneath we're going to have a value of 1,000, and on top we've got 65. But we can simplify that. So how many 5s, if we divide 65, the top, if we divide that by 5, what does that equal? 65 divided by 5 is 13. If we divide the bottom by 5, because you have to do the same, whatever you do to the numerator, you have to do to the denominator. You've got to do the same. So we divide the bottom, we get 200. So what we've done there, we've put the decimal into a fraction and we simplified it. So there's definitely going to be a couple of marks in the exam. I'm going to give that one a tick because I quite like that question. But good marks in the exam, and it's just follow the steps and you can work it out. Let's move on to the next question. This one's a ratio question. Question 3. Only blue and red sweets are in a bag. The ratio of blue sweets to red sweets is 5 to 3. What fraction of sweets are red? So the ratio of blue to red is 5:3. So if we put a B and an R like that, blue 5, red 3. So we want the total. So what's the total? The total. So the total would be, you add them together, the 5 and the 3 will give you 8. So now the bag, so 8 means the bottom part of the fraction is going to be 8. So we got 8 sweets in the bag. How many of those sweets are red? And the answer is going to be 3. So there's your answer. The answer as a fraction is the fraction of sweets which are red is 3/8 equals red sweets. Again, ratio, you need to find out what the total is, and then you've got the bottom of the fraction, and then you just put the whether it's red or blue on the top. In this case, it was sweets. You know, ratio you could use. It might be ingredients for making a cake. But this question, it was a bag of sweets. And yeah, I hope you can see that, and don't eat all the sweets. Let's move on to the next question. Question 4. Fiona drives. She drives for 4 hours. Average speed is 25.5 miles per hour. How far does Fiona drive? I've given you a little bit of help here. I've given you the formula for distance. Distance equals speed times time. So the distance, so we want to know that the distance equals the speed. So the speed is 25.5 times the time, which is 4 hours. So the distance not written very well by me with this pen, equals we can do it on a calculator, is 102 miles. And remember, you need to put in the units to get that little bit of an extra mark. And that's what, you know, in the exam. So it's 102 miles. So you put in the unit and that gives you another extra mark. And in the exam, picking up these little extra marks for the units might be the difference between getting a higher grade and one that was slightly lower. So definitely worth doing. Very important to put the units in. Let's drive on to the next question now. Now, what, 102 miles away in the next question? Or is it just round the corner? Right, Molly tiles a bathroom wall. This is question 5. And the size of the wall is it's 6 meters by 3 meters. Each tile is 50 centimeters by 50 centimeters. So there we've got a bit of a diagram showing the wall and the tile, and we've got to work out how many tiles we need think that's the question. Let's move on. In Molly tiles, a bathroom wall at 6 by 3 meters. Each tile is 50 centimeters by 50 centimeters. Each tile costs £4. We need to calculate the cost of tiling the wall. Right. So, as I say, when you're working in units, the tile's in centimetres and the wall's in metres. So if we find out the area of the wall in centimetres, that's going to help. Let's get the units into the same sort of same value. So if we start off, we make things easier for ourselves. So 1 metre equals 100 centimetres. That's just our little conversion there. So the wall let's work out what the wall is. The wall equals 6 meters times 3 meters, which equals, in centimeters, is going to be 600 well, actually, let's not put it there. Let's put it underneath so we've got a bit more space. It's going to equal 600 times 300, which equals 180,000 centimeters squared. Right, that's quite big. So what is so the tile? What's the size of the tile? We know that it's 50 times 50. So that equals 25,000. So what we need to do is divide. See how many tiles are in the so what we need to do now is the wall, the total wall equals centimeters squared. The tile equals so if we divide it, and what we can do when we're dividing the seeing how many tiles are on the wall, we can get rid of the zeros. 2 off the bottom, 2 off the top. So now I'm just going to scroll down a little bit further. We have 180 over 25 1,800 over 25, which equals how many 25s? If you can do it on a calculator, it equals 72. That value of 72 means we need 72 tiles to tile the wall. But that's not what we're looking for. We want the cost. We know, and if we just scroll back up, cost of each tile was £4. So the total cost is going to be total cost equals 72 times 4. What does that equal? 288. Remember, get the units in. It's not miles, it's not dollars, it's pounds, and that gives us our extra mark. So the total cost of tiling the wall of Molly's bathroom is £288. Yep, quite a tricky one, quite a lot of working out in that. Again, it's just slowing down, going through the steps, working out the size of the whole, working out the size of the wall, working out the size of the tile, and getting them in the same units. Dividing the tile into the size of the wall. That will give you the number of tiles. We know the cost of each tile is £4. We just multiply them together, and then we get the total cost. Quite a tricky. Well, it's tricky. It's only tricky if you don't break it into the smaller steps. But once it's in the smaller steps, you should be able to work through and get to the final answer. I hope that helps. And my music's just finished because it's been quite a long one today. I hope you've hope your music's still going, and well, as long as you haven't fallen asleep, have a nice day, and we'll see you again soon for another Molly's Maths. Thanks a lot, and goodbye.